this video, we're going to be working with how you tell a concentration of a solution. So chemists tend to use the unit molarity, which is simply the moles of solute dissolved in a certain volume of solution. So molarity, which is the moles of solute per liter of solution, and I'm going to be using a slightly different formula. I'm going to represent moles as N, and of course liters is a unit of volume. So I'm going to be using the formula of N divided by V when I go over these slides. So here's an example. It says a sample of oxalic acid weighing 1.2 grams is placed in a 100 milliliter flask, which is filled to the mark with water. What is the molarity of solution? So strategies for doing this type of problem is to first isolate the information that you need. So I start at the beginning, and I'm told I have 1.200 grams. Grams is a unit of mass, and M, as you just saw, is going to be used many, many times. So I actually write out mass, 1.200 grams of H2C2O4. Milliliters is a unit of volume, so V is 100.0 milliliters. And I also write down what is the molarity. So I also write down what it is we're looking for, except for I put a question mark there, because you need to know where you're trying to get to in order to do that. So the formula for molarity we just saw is N divided by V. Molarity is what I'm going to be looking for. I have a volume. I do not have N. So if I go back to the beginning, or in chapter 3, I should say, in unit 3, N is the mass, or moles is the mass divided by the molar mass. So I have a mass given. I don't have a molar mass yet, but I have what the compound is. If I have the compound, I can find the molar mass. So the molar mass is going to be 2 times 1.01, and that represents the hydrogen, plus 2 times 12.01, and that represents the carbon, plus 4 times 16, and that represents the oxygen. And when I add all those together, I get 90.04, and the units that we're using is grams per mole. So now I have both a mass and a molar mass. So N is simply the 1.200 grams divided by 90.04 grams per mole. And I get 0.013327. So you notice that this has 4 significant figures. When I'm doing this, in order to avoiding a rounding error, I always carry it to the 5th significant figures, and this is in moles. The other thing is, so now I have N. The other thing is the fact that the volume has to be in liters. So this goes back to chapter 1, that I have 100.0 milliliters. And the conversion factor that we learned is that 1 milliliter is 1 times 10 to the minus 3 liters, which means it's 0.1000 liters. You could just realize the fact that going from milliliters, which is smaller, to a larger unit, which is liters, means this number has to become smaller, and it has to do so by moving the decimal place 3 times. So moving 1, 2, 3 gives me the 0.1. You don't have to show me this calculation. So now molarity is my 0.013327 divided by my 0.1000. And both of those have 4 significant figures. Well, this one really has 4 significant figures. And so my answer becomes 0.1333 molar. And I can tell it needs 4 significant figures because both this and that have 4 significant figures. And whenever you're doing molar mass, I want you to do it to 2 decimal places. Okay? So always do your molar masses to 2 decimal places. All right? Now, the next problem. If you want to pause and try this one, that's good. Okay. This time it's asking for how many milliliters, and milliliters is a unit of volume. So volume is what I don't know, and I want it in milliliters. I'm putting down what the units are because it asked me, it specified it. Okay, and I have a 0.126 molar, so M, this is doing that a lot today, is 0.126 M, and this is H2SO4. And I have 0.949 grams, and grams is a unit of mass. So mass is 0.949 grams. Okay, I'm going to do basically the same thing. The big M is N over V. Okay, I have M. I want to solve for V, but I do not have N. So again, going back to chapter 3, N, which is the moles, is the mass divided by the molar mass. And I do have a mass, and I can have a compound so I can find the molar mass. So the molar mass is going to be 2 times 1.01, and that's representing the hydrogen, plus 32.07. Depends on what source you look at for, or what periodic table. Sometimes it's 6, sometimes it's 7, plus 4 times 16, and that's my oxygen. And when I add those up together, I get 98.09, and that's in grams per mole. So now I'm going to go back to this formula that my N is my 0.949 divided by 98.09. You see I have 3 significant figures, so I'm going to carry 4. And when I do this, I get 0.009675 moles. Okay, now I'm going to plug in what I have over here. So I have a molarity is 0.126. I have a moles of 0.009675. So when it says not to round, you don't have to write down every digit your calculator gives you, but always one more than what you need by the least number of significant figures, divided by V. Now, whenever I'm trying to solve for something that's the bottom half of the fraction, I need to get rid of the fraction first. So this is division, so the opposite of division is multiplication. So I'm going to take 0.126 times V is 0.009675. And now this is 0.126 times V, so the opposite is division. So I'm going to divide both sides by the 0.126. So V is 0.009675 divided by 0.126. And when I do that, I get 0.0768. But the unit of volume in the molarity equation is liters. It specified it wanted the problem in milliliters, so I need to do that. So I'm going to take 0.0768 liters, and the conversion factor is 1 times 10 to the minus 3 liters is 1 milliliter. And when I do that, I move it 3 to the right because this is the bigger unit, so therefore to get to the smaller unit, the number has to become bigger. So that becomes 76.8 milliliters. And that is my final answer. All right, we're going to pause here and come back and do one more problem for the next section.